We're at Class 1 equipment, Decatur, Georgia today. It's ID 3666. It's at Oxford Plasmalab 133-ICP 380. Has an inductively coupled plasma. Single wafer load lock, but it's a platter that holds multiple wafers on the quartz platter. 380 millimeter electrode in the chamber. Helium backside cooling, helium backside plant. The electrode is cooled at down to -5 degrees Celsius. Chamber and load lock walls are heated up to 60 degrees. It has an Alcatel maglev turbo, ATH 1300M with a 1300M controller. Advanced energy RF power supply. A brand new HP computer with brand new software from Oxford. Runs PC 2000 version 1.8 software. New monitor, keyboard, mouse. We have an Edwards E2M40, fully refurbished. This is the load lock pump. Edwards IQDP 80. And that is the chamber pump. It's the backing pump for the turbo. The turbo and both pumps were sent to pump remanufacturers, completely taken apart and refurbished, tested, sent back to us, and we've run multiple testing on them also. The chiller was sent to a chiller refurbisher. Temperature range is checked. It has been taken apart, rebuilt, like new. The Yalabo FP51 that uses special Yalabo fluid. The 4-line plumbing does not come with the system because we never know how far away they will put the pumps from the system. They could be one level down, they could be in a chase, but we do not furnish these with the system. We have 6 gas pod. And in that we have BCL3, 100 SCCM. CL2, 100 SCCM, SF6, 100 SCCM, O2, argon, and nitrogen, all three 100 SCCM. They have been sent out for clean and calibration, and we have test calibration sheets on those that stay with my rebuild folder. All of our systems, when we bring them in, we take them completely apart. We check all wiring, connections, air lines, 4 lines, and we do replace all O-rings and gaskets and seals. We basically give it a annual PM plus. This is the ICP upper generator. It's an A&E generator, 3,000 watts. And towards the back of the system we have the VAT control, MKS VAT controller, the pressure controller for your VAT valve. To the left of that is the Alcatel turbo controller, and all these run in remote mode. We have system EMO, we have system on and off switch. In the back, the knob there is to lock out the air to the VAT valve if you want to hold it in an open position. Now we're ready to run the system. We also have 2 different quartz inserts. This is for the 76 millimeter. And on the table here we have one set up for 4-inch wafers, 4-inch cutout. Those 2 are going with this system. So now we can close the load lock. This is load lock control. This is chamber control for vacuum only. So I'll tell it evacuate. You will call the wafer. It says you want to name your wafer. You can put lot numbers, serial numbers, however you wish to track your wafers. And this gets data logged in the system so you can pull up the charts after the run and check all your parameters. Alright, so it's open the rough valve to the chamber. This shows wafer in chamber. Shows turbo running. This is your turbo. It's your APC control valve, pressure control. Turbo 4-line, chamber rough, chamber purge, or I'm sorry, turbo purge. So the chamber is pumping down to base pressure. When it reaches base pressure, we'll get two little green identifiers here saying that it is at base. The ones here on the chamber show that the chamber is at base pressure and ready to run. This also shows my wafer clamp is down, my wafer lift is down. Arm is in the home position with the home sensor in the load lock. Now we'll select the process recipe. We've already selected video test. I'll tell it to run. Now it's loading wafer into the chamber. We have our interlocks on the bottom of the screen here showing they're all green and met. The S-Pod interlock, your 3 water circuits. On the right is your voltage monitoring, minus 15, plus 15, plus 24. If they're out of spec, they will turn red. The system will alarm. We're running 200 watts on the platen. That's RF power, RF generator. ICP generator is the big one, and we're running 800 watts on the upper. We have a nice stable plasma in the chamber. We're running 50, our set point is 50 SCCMs for O2. We're running 49,950. 20 millitorr is our set point for pressure. We're running 20 millitorr. And we're running under pressure control. You can run under position control. And we're going to the next step. We're going to run 1500 watts on the upper generator. Has a stabilization time of 15 seconds. Now we have a bit of a brighter plasma because it's more energy. So the only parameter we have changed is the ICP power from 800 up to 1500 watts. Now we're going to ramp it up and do a 2500 watts on the ICP, on the coil, on the upper coil. All the other parameters will be the same. stable 2500 watt plasma. The stand does not come with the system. This is for my test purposes in my lab. But this is the new computer, monitor, keyboard, mouse. So that's the end of running my 3 different plasmas at 3 different powers. Now it's going to unload the wafer. This is your power distribution box. On this particular system, all your power distribution is here. Your pumps are powered from here. Your chiller is powered from here. Your main power goes into this. Inside the upper portion is your PLC controller. Load lock 4-line plugs into this outlet. Chamber 4-line or turbo 4-line in the aft back section. Gas pod interface cable. And your Ethernet to and from your computer. That interfaces your computer to your PLC. Your water circuits all go in here. Your CDA and your nitrogen also come in here. Your backside helium input port, and your main gas box feeds into that section also. In the back are your 3 temperature controllers for your 3 different temperature regions. So that's pretty much it for July 17th, 2013 here at Plasmalab.